these now, right? So 100,000 watts in standard form. We've got to have one digit to the left of the decimal place. And to get there, we're going 1, 2, 3, 4, 5 spaces. So it's 1.0 times 10 to the 5 units remain watts. Yeah, you can do. In this case, I think I've put at least 10 to confirm. Yeah, depends on. These are just numbers that I've written down for a particular engineering calculation. You need to get used to being able to assess the right number of significant figures to include. Yeah. I mean, if I put 10 on the end there, what matter is that 10 watts when we're talking about 100,000? Not very much. Yeah. Okay. But if it's 110,000 watts, then that 10,000 is significant. All right. Engineering form. Where have we got to go to have between 1 and 3 digits? To the left, we've got to go there. So we're 100 times 10 to the 3. Again, units still stay as watts. And 10 to the 3 is the multiple kilo. So it's 100 kilowatts. Yep. This one, standard form, we've got to move the decimal point 4 places to the right to get a number in front of the decimal place. So it's 5.4, and move 4 places, so it's times 10 to the minus 4 amperes. Yeah. Here, we've got to move 2 blocks of 3 to get to 540 in front of the decimal place, times 10 to the minus 6, again, amperes. And that is 540, 10 to the minus 6 is micro amperes. Yeah. This is 1.5 million. There's one. We've got to put a decimal place there for standard form. So that's 1.5, 1, 2, 3, 4, 5, 6 places. Ohms. And in this case, 6 places as an engineering form, so it's the same. And in unit prefix, what is it? 10 to the 6 or a million is 1.5. Anyone? Megos. Now it's a bit tricky. We're going back the other way now. We've got 10 to the minus 2. Yeah. Minus 2 is moved to the right, so we need to move our decimal place from where it is to the left. 1, 2, so we've got to put a naught in there and put a naught in front of it. 0225 volts. Yeah. Engineering form, what we got to do, we've got to go one more place to the left, 22.5 at minus 3 volts, and that's 22.5 millivolts, lowercase m. Standard form, how many places to the left? 10 to the 10, yeah. Hertz. engineering form, that'll be 35 times 10 to the 9. That's 435 and 10 to the 9 is gigahertz. 1.5 microfarads in engineering form is 10 to the minus 6 farads. Must be the same in scientific form, and that is 0. Make sure I get enough zeros. 5 zeros, 1 5. Now, you can kind of see with them kind of numbers why you want to use this power 10 notation, because under pressure you could quite easily put an extra naught in or leave one out on your calculator and get factor of 10 either way as an answer. Okay. 12.65 times 10 to the 3 joules is 12.65 kilojoules. It's 1.265 times 10 to the 4 joules in standard form, and it's 12650 joules. Right, and you're going to be doing lots of that, working with different multiples and so on, and you need to get comfortable with being able to use. We won't be using standard form a lot, but I keep it here because that's what engineering form is derived from. Yeah. Okay. And usually your calculator is going to go into standard form that you'll then want to convert to engineering form, so that you know how many millivolts or kilovolts it is. All right. Very down to time 4. All okay with that, up to a point. Okay. Now, going to make a start on to talk about basic algebra. It is the grammar of mathematics. They are important skills. Okay. The best way you can practice that is to practice what I put up for you on the Khan Academy, as well as what we do in class. Okay. But I haven't got the time to go over these techniques over and over and over. I'm going to quickly go through them, and you apply them. Once you practice, go on there, and I'll help as much as I can. Okay? But it's things like expanding, factorising, simplifying. Okay? What we do is we use symbols to represent numbers, constants or variables. A lot of people get hung up with algebra because it includes letters and Greek symbols. But don't worry about A. A is, we rewrite A because that's a number, that's a constant, we don't know what it is yet. B, constant, we don't know what it is yet. Y is your kind of de facto independent variable. But it's called Y because we don't know what it is. We want to know what it is, for instance. Okay. So they just represent numbers. It could be decimal numbers, it could be a fraction, could be just an integer. Okay. We've already done this, but 3a minus a is equal to 2a and not 2. Alright? Okay, looking at that diagram, thinking of that as maybe a sheet of metal or a piece of paper. Okay. How could we express the area? Give me a way that we could express the area of that rectangle. Yep. we could say that the area of that is equal to 2y. You don't have to, but it's normal to put the letters representing constants in alphabetical order. Okay. Now, is there another way that we can express that? Two x times y. Just explain to me where you get that from. Yeah. So that distance is 2 times x. And 2 plus x. Yeah? Put it in blue. Y equals 2 plus x times y. Yeah? Now, if we factorise this one, what do we get? How would you factorise that? Factorise means take common factors outside brackets. Y on the outside. Oh, look at that. Yeah. So we've taken the expression that way, we've factorised it, we've ended up with that one. Yeah? What about if we multiply out the brackets? Let's call expand that expression. What do we do when we expand the brackets? Yeah, we do y times 2, we do y times x. So what do we end up with? 2y plus xy. Oh. So they're just different ways of writing the same thing. We're manipulating it so that we can do something else with it. It all depends on which one of x and y we know, and then the other one's the one we want to find. So we do this kind of either factorising or expanding manipulation to get the expression in the form that will give us the answer that we need. Yeah, because we might know our x dimension and we're trying to find out what the y dimension is using the formula. So we need a formula that says y equals something. Or we might know y, we might know y and need to find x. We might know the area and need to find x and y even. Some other parameters. Okay? So just different ways, didn't mean to do that, of expressing. Right. Have a go. What 2 ways can you express that? A couple of minutes. 2 different ways to express that. Right, any ideas one way to express the area of that? From? Yeah. So why? What? Yeah. What's another nice way to write y times y? Yeah, so we're saying area is equal to y squared minus x squared. Yeah, we've got this. Y squared would be the whole square, and then we're taking away that bit which is x squared. That's one way to write it, yeah. Another way? No, it's not the same thing. What's that bit? And what's this bit? So how do we express that now? Think of splitting it there. What's that distance? That's x, isn't it? Yeah? So now how can we express? How can we express this square here? What about that bit up the top? No, just this bit. Y times yep, agree? That bit's y minus x. That's y, so the area of that top rectangle is y times y minus x. And the area there is x squared. So we could write this as I is equal to x squared plus y looks more complicated, but whether you need that version or that version depends on what you know. And anyway, this could be manipulated. So what happens if we expand the brackets out? Well, that's x squared plus y squared minus xy. That don't look right there to me. No, that's not right. I can see what it is, guys. Deliberate mistake made for you to notice. Right? There's nothing to say that's x. Sorry, there's nothing to say this is x. that is x there because that's labelled x. There's nothing to say that bit there is x. What is it? Let's just label this up again. Yeah, this is this. Sorry. That bit is y minus x. That bit is definitely not x squared. Yeah, it's x squared. So now, what's the second way to express our area? Sorry? No, sorry, this one isn't, is it? No, that's y minus x times x. That bit's y minus x, yeah? That distance is x, that distance is x. So that's y minus x. That is y minus x. So that bit in there is x times y minus x. That bit up the top is y times y minus x. So the total area is yeah. If we expand, what happens? Yep. Now, we've got plus xy there and minus xy there. So they cancel. What we got now? They're in a different order, but we've got what we got up there. Minus x squared plus y squared is the same as y squared minus x squared. Yep. Okay. Sorry about that little miss of a mistake there, but we learn from that, and that's learning how easy it is to go wrong if you're not careful. All right. Right, that's us done for today. All right, so we'll pick up where we finish next week and move on to a few other bits and pieces too. All right.